We'll begin here in just a moment once we hit 6:30, so we'll start here in about 6 minutes. All right, good evening. We're going to start off with Chapter 5, Data Processing. Thank you for everyone for showing up. Just a reminder that all case studies are due as assignments and they will count against you if you do not submit them. All tests are due for each chapter and they will count against you if you do not submit them. So please make sure you are submitting them before the end of the semester. Those are critical assignments and your essays are also due. I apologize for this last essay. There was a problem with the AM/PM portion of the submission date and time. I think we got that corrected. I will be very cautious with the dates and times on those essays. So, moving right along. Data processing. What is the purpose of a database? What is a database? What is a database management system? How do database applications make databases more useful? How are data models used for database development? How is a data model transformed into a database design? And then we are not going to cover the eHermes or the 2031. So, as a reminder, if you have questions during the lecture, please text me on my phone. We are not going to be utilizing the chat feature of YouTube. So what is a database? Well, a database is an organized way to keep records and track them in multiple themes. Now, we use the term themes when it comes to databases, and this is the easiest way to think of it. When you have a single theme, you would use an Excel spreadsheet. If you have multiple themes, you would use a database. For instance, their example here is student grades, student emails, and student office visits. That's multiple themes. Therefore, you would use a database. If you were strictly keeping track of student grades, that's a single theme, you would use a spreadsheet. Now, here is an example of student name, number, homework 1, homework 2, midterm, homework 3, homework 4, final. This is student grades. It's a single theme. That's why it's a spreadsheet, okay? Now, here is the form that you would use for student, but it's got embedded forms in it as well, embedded tables for email and office visits. So this is for a database because it has multiple themes. Now, in a database, you use columns just like you would in an Excel spreadsheet, and you use rows to identify them. Characters, also called bytes, are the individual items. Like in the bottom here, they say Y and 9. Those are called bytes. All right. Table or file, that is the individual file of each individual student. The row or record, again, is the individual, that one particular student is the row or record. The fields, those are the student name in the file, row or record, or excuse me, in the row record that's in the table or file, and then so on and so forth as it builds, okay? So again, another pictorial representation, tables and files, plus we're going to talk about the relationships between the tables, which create the ability for you to make queries and start pulling data and reports or building more usability and functionality, and then the metadata that comes in beneath it and how you configure your database, how you show the relationships, and how you show what the data actually means. And that's what all comes together to build a database. Here's pictorial representation of that. So these are showing you what a key is. Now, they're not explaining that it's a key, but they're showing you how you are utilizing unique identifiers in the student number table, or excuse me, student table. They're showing you that student number is a unique identifier per student. And it's also showing up in the student number, in the email table, student number showing up there, and in the office visit table, student number showing up there. So now we have relationships between both of those tables. So we can link those tables together, and now all of that data can be pulled in a report or in a form like you saw before, and it is able to be shown together. Here is the metadata or the configuration data. You'll see that you have an ability to do input masks. I'm looking at the bottom section, the field properties, and how you're formatting the actual data. This is a short date for the date, the one that we've got highlighted above. So this date is a short date. Its input mask is 99/99/0000 semicolon 0 semicolon pound. Now that is a required input mask, a required format for data being input into the system. If it goes in any other way, it won't accept it. All right. The default value is equals now, parentheses, open parentheses, close parentheses. So what you will see in this field is the current date. That is why that's there. So a database management system. Now, it allows a database programmer or a database administrator to create, process, and administer. So you're going to see this with Microsoft. That's going to be Access or SQL Server, Oracle Database, IBM's DB2. They also have a myriad of others in the world that you will probably won't ever deal with, but you'll see. There's web development program languages, on and on and on and on and on. Open source, MySQL. Anyway, tons and tons of different database programming languages. But the basic operations that you're going to have is read, insert, modify, and delete. Quick way to think about that is you're either going to look at it or you're going to write. Okay? Your functions that you're going to have, read or write. Okay? If you're modifying something or inserting something or deleting something, well, you're writing something in a database, right? And everybody's like, well, if I'm deleting, what am I doing? Well, you're overwriting data with null values. Okay, so you're either reading it, selecting it, pulling it out so you can look at it, or you're writing something. That's a quick way to look at it. Now, structured query language is SQL. That's a shorthand for it. It's an international standard. It has select language in it that can't be changed, and when you use those certain phrases or words, it's going to tell the system to do something, right? So if you look in at this example here, insert into, those big capitalized words, right? Those are reserved words. Insert into student, that's going to be your table, okay? And then below that, student number, student name, those are all individual items inside student, okay? So insert into student, then the values. So 1000 is the student number, Franklin, Benjamin is the student name, 90, 95, and 100. Those are the grades. Those are corresponding values for what you see above there. So again, you're going to see in the email table, that's what this table is right here. This is the configuration side of a database management system showing you what the response format is, right? This response properties of this table for response, excuse me. And so response question mark, yes or no. So it's a yes, no answer, true or false. It's, it's pretty simple. Default value is no, indexed, no. So that is something that is going to be posed to the person when they hit this form, yes or no. Now, database administration. You have to set up security, user accounts, passwords, permissions, and the best way to think about this is you want to only grant what permissions are required based upon the user's necessary rights, okay? Then you want to make sure that as you administer a database, you have a backup and that you are doing everything in your power to improve performance of the database and the applications to do it. And then you are purging data to keep the performance of that database at premium performance, okay? All right, I'm gonna let you go back and look at all those tables with information that as your time sees fit, because we're gonna move on. So how does a database application make databases more useful? Well, you have forms, reports, queries, and application programs. Well, each one of those are utilized by the end user to be able to either pull data, insert data, manipulate data, or insert or delete data from the database management system either from a direct interface, a thick client, a thin client, or a cross-network interface so that the data can be managed. You can also throw in web application, cloud application management in that, the application access for those users as well. These applications are used to do that read and write functionality to be able to make the database more useful, okay? So this is a report that is utilized by end users. They can create this or they can run it so that they can see the information for, say, Andrea Baker, the student. This is her information. Email date. This is her email that she sent to someone with a message of, my group consists of Sui Lau and Stuart Nelson, okay, with the homework grades 1 and 2 inside there. So it's pulling data from 2 different tables, 3 tables, the student, the email, and the homework table. All right, now, you can also put questions in there to ask for parameters to help pull information, right? So if you know there are certain phrases or certain information in your database that you need to be able to pull from, you can build a parameter query, okay? Or a parameter value query. So if you know that, like Miss Andrea Baker put in her notes that Andrea had questions about using IS for raising barriers to entry. Well, you know that enter words or phrase for search, barriers to entry. This looked through the entire database or through that table or whatever your value for this parameter value search, and it found barriers to entry, and it returned this value. So that is a simple query that you can build to help make the database more functional, okay? So database applications, making the system more useful, right? You have multiple browsers coming to the internet, accessing all those applications with web server computers, right? And that's either utilizing HTML, CSS3, JavaScript, going out towards the internet, and then towards the actual database management system, you're using Java, Node.js or JavaScript, C#, and then towards the database server itself after the database management system processes it, okay? So this would be a user management interface. So this would be how you would set up user profiles, or this user would actually come into this with, this would be a user profile. So they could add their picture, update their first and last name. This might even be where you would go to create the user themselves, right? But they may also come to the same screen and change their password, manage their address, and go passwordless, okay? This is yet another form of database. So SharePoint is another database, right? This is MIS Books. So this would be where we have created an internal database in SharePoint. This is not the school. This is just another illustration. So MIS 11E, MIS 10E, 9E. So you see all those at the top of the screen, excuse me. And then the contents and subtitles or subsites below. This is just a database, right? So this has contents. This your left would be, your left. Well, whatever it is, your left, my right, whatever. Site contents, planning documents on your left, and then all the documents and content, site assets in the center. Again, just a different type of web access application for a database, okay? So here's another pictorial representation of that. Forms, reports, and queries. So your requirements for creating data models and entity relationships, data model, creating database design, tables, and foreign keys. This is creating the database, right? So let's back up, and this is how you would create a database, okay? Let's say you're designing it on paper. So you would design before you did forms, reports, and queries, my opinion, you would design your requirements, your data models. Then your data model would create your database design, tables and foreign keys and what all you would require. And then you would build your database. And from all that, you would be able to have your forms, reports, and queries. That's the order in which I would build a database. Here's an illustration of all those tables we've been talking about so far, plus advisor, department, and we've already seen the email, and student, but we're also adding department, office visit, and advisor. Okay, so how do data models used for database development? Well, here you go. Accounting branches out into the three users, Jones, Wu, and Lopez. And then as you see here, I'm not going to go through each one of those links into 100, 200, 300, blah, 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 blah. You can see all those advisors and what student entities they go into. Okay, so your data model used for your database can show you the relationships and the requirements and all of these entities as you go through it. Okay, so an entity, it's a noun, right? Subject, it's a thing to track. Order, customer, salesperson, yada, yada, yada. An attribute describes the characteristic of an entity. An identifier usually identifies one entity instance from another instance. Okay, now your relationships can show one to many, many to many, but that is depicted by these little crow's feet or these little lines. So between department and advisor, you would have a one to many, right? So one department has many advisors. Advisor to student, you would have many advisors has many students, right? Now, a department that has many advisors would have many departments, has many advisors. One advisor has many students. So you've got to be able to determine those relationships as you're building your database. Okay. Now, cardinality. Cardinality. It's the maximum number of entities in a relationship. Vertical bars on a line means at least one entity is required. Okay. That's maximum cardinality. Okay. So you have to have one department. You have to have one department in that relationship between department and advisor. Okay. But minimum cardinality, minimum number of entities in a relationship, a small oval means the entity is optional in the relationship. So you need not have the entity of that type. So if you see an oval, you may not have to have it. So you have one to many advisors, but you can also have one department with no advisors. Interesting when you come to cardinality, huh? One advisor to many students, but you can also have one advisor with no students. So when you start thinking about cardinality, it's interesting. Normalization. So when you're normalizing a database, you're converting those poor structured tables into two or more well-structured tables. So if you have an obtuse table that has too much data, split it, right? And then make it easier for the system to manage, easier to understand, make it more logical. The goal is to have single theme or entity, right? If you have multiple themes in one table, you've done too much, right? You do not want to have data integrity problems. That's the whole point of a database, is to not have data integrity problems and to make it simple. If your database is difficult to understand for you, it's going to be difficult for the system to process, right? When you have integrity problems, you're going to have bad data. You're going to have bad information. Your users are not going to have confidence in your information. And your system's going to have a poor reputation. Nobody's going to want to use it, right? So here's a pictorial representation of the employee data before update and the table with incomplete update, right? Now you're seeing it afterwards. Now you have a department and an employee table. So you want to represent each entity with a table. Each table has a key, and each attribute becomes a table column. You normalize the table as necessary. Represent relationships with foreign keys. So the key is represented, the primary key of one table is represented as a foreign key in another table. If you think back to when we were looking at the student number showing up in all those other tables, that would be represented as a foreign key. And an additional table for a many-to-many relationship. So here is a pictorial representation of all of those things we just talked about. This is a good slide to reference. Well, all of these as we go through, okay? Now, the final judges of your database, and if it is a quality database and if it's usable and functional, are going to be your users, right? The review of your data model, entities must contain all data users need to do their job. Must accurately reflect the view of the business. It must be taken seriously, and you have to devote time to it, all right? We're skipping Hermes 2031, sorry. All right, now we're moving over to chapter 6. Give me just a moment. All right, chapter 6. So what you are looking at here now, or what we're looking at here now, is the cloud. So there's quite a bit to cover with the cloud. We're going to skip over a little bit of it because it gets very redundant, so hang in there with me. So why is there such a large migration to the cloud? Why do organizations want to use it? What network technologies support it? And how does your internet, or how does the internet work? How do web servers support the cloud? And then, of course, we're not going to look at eHermes and or how can organizations use cloud services securely? We're not going to look at that, and we're not going to look at 2031. Okay. Now, why are organizations moving to the cloud? Well, it's elastic, it's pooled, the ability for them to be able to adjust the demand and the size, the economics of scale, but most importantly, it's the finances. And it doesn't come with the same financial risk that trying to do an on-premise network, on-premise storage, on-premise servers, and all the things that we've done for decades comes with. So let's look at the history behind this. So from the 1960s to 80s, mainframe era was prevalent. You know, IBM was king, large-scale, high-speed computerized or centralized computers and thin clients, no internet, no cloud. Then we moved over to client server. That was only about a decade, 1990s to 2000s. We still have a lot of that trickling over. A lot of people are not comfortable moving to the cloud. We still have what I like to call the blue hair mentality. They don't trust it. They want to know who is controlling their data. They want to know where their data is. Well, you can't always explain that to people, but the best way you can put it is your data is being housed on someone else's equipment, but it is securely set aside. They can't access it or see it. It's your data and it's your hardware. You're just leasing hardware from somebody else. It's their responsibility to keep it secure, up to date, and connected to the internet. So they're taking on the brunt of the cost. You're just leasing. Okay? So this is 1960s to 80s. Thin clients, local network mainframe. That's where it stopped. Right? It was all in-house. So 1990 to 2000, standalone client, went to the internet to a server. So you could actually hit a server remotely between buildings, but it was client to server. Now, cloud computing era started in about 2008 to current, and technology has boomed and become absolutely cutting edge. We see it now where AI is starting to jump into this as well, but you have computers, PCs, clients, mobile devices, Internet of Things, yes, but also we have what's called software as a service, where you can actually host your software on the actual cloud and not actually have any physical devices on your network. All your software is hosted there. Infrastructure as a service, you can actually host almost your entire company on the cloud without having much of any kind of hardware at your facility except for switches and routers and internet connectivity. You are almost there. Now, why are they moving to it? Because it's making it easier for all of your devices to be able to access all of your systems, all of your data, anywhere in the world at any time. The lower cost, cheap processors, essentially free data communication and storage. It's ubiquitous, your access. It's improved scalability, it's elasticity, virtualization of technology. All these things I've been talking about so far. So you'll see from this scale, again, you'll see it stops at about 2020, but it's gone up from 1.1 in this revenues in billions from 2014, quarter one of 2014 to quarter one of 2020. It's gone up from 1.1 billion to 10.2 billion at Amazon Web Services in revenue in billions. That's one company. And that's only been in what, 5 years? Yeah, 5 years, 1 quarter. All right. Now, here are the positives. You know, small capital requirements, quick development, known cost structures, right? It's growing and fluctuating. It's superior for scalability. You know, you get best of breed in security and disaster preparedness, no obsolescence. Industry-wide economies of scale, hence it's cheaper. You focus on core business, not infrastructure. Those things are fantastic. It's once you get people to buy into the positives and see that the security is there to maintain it, as long as you can maintain the security on your side and guarantee the security on the other side, then you're good to go. Negatives, you are depending on your vendor. Loss of control over data location, and little visibility into true security and disaster preparedness capabilities. You do have to depend solely on your vendor for that. So, let's talk about resource elasticity. Well, car manufacturer runs an ad during Academy Awards. Doesn't know if there will be 1,000, 1 million, 10 million, or even more site visits. Cloud vendor will programmatically increase server capacity. Car manufacturer reduces costs substantially. So that is one way that you can overcompensate for preparedness, but not actually add cost. How do organizers use the cloud? Well, volume of data delivered. You can see that peak usage over 60 gigabytes per second happens at 2 p.m. and then you jump to almost 40 gigs per second at 5 p.m. But the rest of it averages no more than between 15 to 20 all day. So you can sit here and know you're going to have peak scalability between those 2 hours, and you can average out your cost with your data deliverability. That's nice. Without having to actually say, okay, I know I have to have minimum 60 because I have those peak times. Well, then your saturation is going to be next to nil because the majority of the time you're not hitting that peak. But you know that you can hit those peaks and you're not going to get hammered for the rest of the day because you have 2 times a day that you're going to have peak. That is what the benefits of having cloud infrastructure are, because they'll be able to absorb those peaks and you'll only pay for the peaks and not have to handle a static number to be able to handle the 2 times a day you peak. Okay, so your economies of scale, average cost decreases as size operations increase. Major cloud vendors operate enormous data centers or web farms, right? So here is Apple's billion dollar facility that contains more than 500,000 square feet. That's a data center, a web farm, right? Huge. So they maintain that so that we can save our 2,000 or 3,000 pictures per phone, right? And not worry about losing them and have our 3 backups per user. Maximum response time. That's something that can be negotiated for a business. right? You can have your SLA, or service lead time, or service lead average, or whatever you want to be able to refer to it as. Cloud vendors provisioning servers all over the world nearly instantaneously. Most of your business structures will allow you to have 3 different cloud infrastructures, or some of your business structures will allow you to have your system replicated at 3 different physical localities, so that if heaven forbid, 2 physical localities get knocked out by a natural disaster, and this would have to be a massive natural disaster that took out 2 countries that aren't even physically located in the same continent, a third one would be able to pick up and go. Uses current internet standards for sending and receiving services, and those internet services can be exponentially increased as data needs and internet needs become higher per user. Okay, so organizations that use the cloud, you manage and the vendor manages. So take a look at this pictorial representation. Okay, again, we've talked about software as a service, process as a service, and infrastructure as a service. So take a look at these. Okay, now content delivery networks. Stores use data in many different geographical locations and make data available on demand. That's awesome. Okay, used to, it took time. Right now, this minimizes latency, and it's used to store and deliver content seldom changed. So here is a great representation for media company and home users. So if a media company is actually broadcasting, home users can be able to access it across the country almost instantaneously. Okay, so adding in those CDN servers, that's what the instantaneous part comes into play. Right? Before, there was a delay and a lag time. Here's where the instantaneous comes in now. So these content delivery networks, they decreased even guaranteed load time, reduced load over origin servers, increased reliability, protection over DOS attacks or denial of service, and reduced delivery costs for mobile users, and they are pay as you go. Right? Now, private internet, right? So if you're going to use an inventory application for a web server attached to a database management system with an internal database, you've got all the different browser applications for customer service, sales department, shipping, and accounting, your private internet is going to be utilized for a cloud infrastructure so that it's accessible everywhere, especially if you're an international company or a national company that needs to be able to access this in numerous places. All right, so how does your network work? How does network infrastructure play on this? So you have personal area network, local area network, wide area network, and then you have the internet and internets, or network of networks. Okay, so here's a pictorial representation of network technology and how it interacts internally and then hits the internet itself. This is something to be able to reference back to as we learn. So your communications equipment, and then it goes into kilo or 1,000, not 1024 like memory. Mega, a million, not 1024 times 1024. So think this through here. Giga is a billion, you know. So keep track of this slide as well as you start talking about communication speeds, right? It's the century numbers, not the 1024s, right? Okay. So you got your IEEE communication. So your wireless LAN is 802.3. Your wired LAN, excuse me, is 802.3. Your wireless LAN is 802.11. Okay. The current communication speeds is AC speeds of up to 1.3. This is actually from 2022. Again, when the book was published, I think we're up to 6, and so that puts us at 2.5 to 5 gig connectivity speeds for Wi-Fi, and then we also can throw Bluetooth in there as a tertiary connection as well with Wi-Fi, but it also used for transmitting short distance for computers, connection, keyboards, mice, and you know that entire list there as well, right? Your ISP, or your internet service provider, is a legitimate. They provide a legitimate internet address, a gateway to the internet, and access fees and other charges to telecoms, right? Sorry, my streaming software disconnected. Let me reconnect here. So This slide and this slide are very good pictorial representations of internet connectivity. So inside your internet connectivity, you've got your assemble package, your name of the package, your lookup address, the put address on package, your registered mail sticker, and your ship package. So again, that is a physical package. But if you take that across over to your internet equivalent, your assemble package is your packet. Your put name on package is your domain name. Your lookup address is your DNS or domain name service, right? Your put address on package is your IP address, right? Put registered mail sticker, that's your TCP. And then your ship package is your carriers or routers. So there are two different types of internet addresses. For the longest time, we've used IPv4, which is four sets of octet numbers, dotted decimal notations. There's only about 4 billion addresses. We do not have enough. We've been doing all that we can with a lot of really interesting methodologies to continue using them. And I've been hearing ever since I was getting my bachelor's degree and now have my doctorate that we need to move over to IPv6, and I still do not see us doing it in a fast enough fashion. So hopefully one day we will figure out how to get over to IPv6 in a unified fashion, but I don't know. IPv6 is a hexadecimal notation with 340 unidecillion addresses and should fix everything we need, but it's much harder to do and people have not adopted it. Your domain name, it's a unique name affiliated with your public IP address. URL, uniform resource location, it's your internet address. Public IP address, it's your identifier and a unique device on the internet. So this is your outside address, your private IP address, right? Usually a LAN, assigned LAN controlled IP address on the outside. Public IP address conserved, one public IP address per LAN, right? You can get more, but you got to pay for them, just so you know, okay? Using private IP addresses eliminates registered public IP addresses with the ICANN approved agencies. Yeah, there's a bunch of them. Now, yeah, this is just one of many. You can use this one. You can use GoDaddy. You can use, there's a bunch of them. This is a domain registry site, if you didn't realize that. Domain registry site where you can go and register your domain, get an IP address, do your DNS, TCP, all that online. You can use GoDaddy, you can use all sorts of different places. Now, packets and carriers. Well, messages are broken into packets. TCP guarantees delivery of packets. Packets move across the internet. And peer agreements, carriers freely exchange traffic amongst themselves without paying access fees, right? So it's the handshake amongst your routers to say, hey, this is where this goes, this is where this goes, right? So this is a picture saying, hey, you're in Seattle, your local area network, your internet service provider, and then there's 4 different networks here talking to each other saying, oh, that's where he is. And then you get to that internet service provider on the other side, big banks like local area network, and then you get to friend at big bank. So that's a rudimentary pictorial representation of how it works. Net neutrality. Net neutrality passed a few years ago because internet service providers were limiting the amount of communication that other ISPs could send across their network and causing latency and allowing their customers to have better communication. And now it's required that all data is treated equally, no matter who is sending it. You have to treat it all the same. Carriers should not be allowed to decide which sites load quicker, which apps are allowed on their network, and which content is acceptable. So supposedly that fixed it. I still say there's something hinky going on out there. But Netflix, for example, problem. Some people use more bandwidth than others. Well, Netflix, for example, accounts for more than 40% of all internet traffic in North America between 9 p.m. and 12 a.m. Really? Who would have thought? Web servers. So Zulily. Anybody gonna go shopping? All right. Zulily comes from web browsers attaching to some kind of a web server like Apache or IIS. And then there's a commerce server application or other applications sending instructions or data to a database management system, going to a database, and then the response goes back the other way, all the way through the DBMS, sends more instructions and data back to the application or commerce server application, to the web server, and then back to the web browsers for the user. And it's just a back and forth. So it's repeating itself more and more. So, all right, we're going to skip ahead here. Web servers. How do web servers support the cloud? Okay, so how do web servers support the cloud? Well, services. They obtain part data, part images, part quantity, on hand, and order parts. So this is an order system, right? JavaScript is written to invoke these services. So there's a pictorial representation of what we're talking about. The browsers, they go into a load balancer. Load balancers are used when you have massive amounts of users hitting the same web server or multiple web servers. It says, okay, you go to this web server, you go to this web server, you go to this web server, and then it sits there and does a round robin so that one web server doesn't do all the work, okay? So if you have 1 or 3 or 100 or 1,000 web servers, etc., you have 100 web load balancers and you have 1 million people trying to get it, then let's say you have 1,000 web servers and 1 million people trying to get it. Each web server is going to get 100 users, okay? And then you need to have at least 100 database management systems and 100 copies of your database that all unify together, blah, 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 blah. So you see how this works. All right. Web server protocols that support the cloud. You got your HTTP or hypertext protocol. You got secured version of that, HTTPS, which utilizes a server certificate, which makes it all secure. You want to use that if you're doing any kind of credit card or PII, personal information. SMTP, used for email transmission. Then FTP, if you're doing any kind of file transfer, so used to move files over the internet. Google Drive uses FTP behind the scenes to transmit files from their cloud servers to you. Hopefully, they're actually using SFTP and having some kind of a secure service, right? Now, web servers support the cloud, so you've got web server protocols like WSDL and SOAP. Application layer would be your HTTP, HTTPS, SMTP, and FTP, right? And then internet plumbing protocols. So you got 4 more layers of protocols in that internet protocol, TCP/IP protocol architecture that are below that, right? So this is a breakdown and illustration and description of all of those. I'm not going to go into those. This is an actual illustration, of those languages. Okay, and this is the Hermes. Okay, and let me see where we're at here. Hang on just a second. Where's my mouse? Okay, and we are done. Thank you very much for attending class tonight. If you have any questions, please let me know. I am going to be grading this week and getting everything caught up on grades. If you have any questions, please reach out to me. Other than that, thank you all very much and have a wonderful